Hi, and in this video I'm going to do a demonstration of concept of the SEER device, the SenseItAll instrument, and the use with ZP sensors for measuring hydroperoxide. As I say, this is a demonstration of concept because we haven't moved the um, hydrogen peroxide sensor onto the SenseItAll platform. So there's at ZP we have technologies like the SenseItAll, which allow us to put a sample onto a sensor, send the data to the cloud, process the data, and send the result back to the phone. If you've watched any of our caffeine demos or our chili demos or our ginger demos, you'll see that proof of concept. Not proof of concept; those are actual products, but you'll see those products in action. Now at Zimmer Peacock, we do have a whole host of biosensors, including hydrogen peroxide. But for each one of these sensors, some of these have been moved onto the SenseItAll platform and some of them haven't. So for each one, there is a program where people will engage us and we'll move that sensor onto the platform, and then they'll have a kind of point of care, point of need diagnostic for that particular analyte. With that said, let me dive forward and actually do a demonstration. So what I'll do then is I'm just going to take some tap water in the first instance. So I will take a pipette. I'll just take some tap water. I will put the sensor onto this. Now, this is just really a concept. I will use hydrogen peroxide to demonstrate this, but I haven't done the kind of calibration curve and all the kind of optimization that's required. What makes biosensors trickier than just PIP sensors that people are typically kind of used to is that lots of sample types can have lots of different calibrations. So you have to you can do hydroperoxide in milk, you can do hydroperoxide in drinking water. Those, for example, would have different calibrations. Now what I'm going to do is I'm going to go in and just call this tap water so that I can find it, tap water. And I'm just going to gather some raw data really quickly. But the nice thing about the SenseItAll platform is it allows us to do the R&D quite quickly on such a sensor. And it will then allow us to do something like, the detection of hydroperoxide. So I'm just going to do a quick first run on this. And then what I'm going to do is do a second run. So what it's doing now is just uploading the data to the cloud. And then I'll come in and do that's just tap water itself. And then I'll do a run with hydrogen peroxide. So what it does is we've got a cloud database called Djuli. It sends data to the cloud, and that's what it said here. It says upload complete. And that's great, see, because up there we can actually put what we call universal calibration factors, which would actually turn the raw signal actually into a concentration and then send the data back to here. Now what I'm going to do is I'm just going to take that sensor off for a second. I'm going to bring in a millimolar concentration of hydroperoxide, probably sub-millimolar. Now the reason I'm a bit wary on it is because I've made it using rather chemicals that I've have in the household, so I'm not entirely confident that the concentrations that they're reporting are entirely correct. But I'll just take a sample here. I'll put it onto the sensor here. Just notice how easily I was able to change that sensor over. It's one of the it's the ease of use that makes this instrument particularly powerful, especially when you're trying to roll it out to less technical people. So I'll just put hydrogen peroxide so I can find it. Hydrogen peroxide. Right, done. Okay, and now I'll go continue here, and now it's running here. So similar experiment to before, except now we've got hydrogen peroxide in the sample as well. And what I'll now do is that says upload complete, so I'll go done. So we do have a cloud system, as I say, called Djuli. Every time we do a run, the data goes to the cloud. It's really great because it means that you can have less expert people doing sampling, but you can also, and they can get a result on their phone, but you can also send that result to the cloud as well. So what I'm going to do now is I'm just going to go up to, I'm just going to share the screen with you rather, which is, screen 2 here. I'll just put in the words demo, because that was the cluster that I was saving my data in. Demo here. And then I should get a couple of I've got a whole load of tests in here. There's my device itself, and I have a whole bunch of tests in here. One is tap water, and then one is tap water hydroperoxide. So the good thing about this is that every time somebody does a test, they can have a result on their phone, but they can also you can have a result up in the cloud. So I can see the kind of raw signal for just tap water. I say itself here. I could download this, by the way, but I've got the name, I've got the date, I've got the time, I've got the operator. That's all very good. If I go into hydroperoxide, I'll go back this way. You'll also see that I've got the time, the date, the operator, etc. So that one's hydroperoxide. And in a minute then I'll overlay the two as well. So you can see what I'm sort of doing here in this demonstration of concept. In fact, I can see the hydroperoxide signal is a lot higher there. So no, there's a massive sort of difference there. So what I'll do now is I'm just going to overlay these two things. This is almost now like if we were to do the translation of the sensor onto the SenseItAll platform. This is kind of, the first step, let's say, of just doing that translation. I'll combine those two reports. And so that will just allow us to see the sort of difference between the tap water and the tap water with hydrogen peroxide. As I say, we've also explored things like milk in the past as well. But for milk, you would need there's different interferences. So the calibration will end up the calibration routine would be slightly different. So what now I can now do is if I just do this, I'll be able to see the two sets of data, one with and one without. As I say, this is really a demonstration of concept. So you can see the difference here, that with the hydrogen peroxide, we get this kind of big difference. I just want to do a bit of analysis on that now as well. So what I'll do is I'll just go to here. Whoops a daisy. I'll just go to here. I'm just going to, linear sweep. I think that will do it for me if I think about it a little bit. What I'll do is actually I'm just going to cancel this for a second. I'm just going to save this report, and I'm going to go back now and show you how we can start the process of translating the hydrogen peroxide signal into something meaningful. So if I go to here, reports, and then I click onto my data with hydrogen peroxide. Data with hydrogen peroxide here. I can see my result, and then I'm going to analyze it. Well, I know where my signal was because of that overlay that I just did between the two. So I'll come down here. Right, now I'm going to kind of choose a nominal, something like 850, and I will turn 850. So tools, properties, video, show extracted data. Let's look for a peak height at about 850 millivolts. Now this is what the kind of universal calibration that we would end up developing. But we find that over the years we found that the best people to take the first lift at this are actually ZP. Academia is very keen to kind of do this kind of work themselves, and they're very welcome. But when it comes to, I want to say, real companies, then their time is more valuable than that. So in fact, we like to do the first lifting on this kind of thing. So what I want to say now is if I go down here, what it's done now is it's found the current at that particular voltage. So it's, you can see now it's kind of starting to automate that. Now what I want to do now is I just want to give this a nominal, I don't know the calibration, so I'll assume an intercept of 0.5. Bear with me because I've not done this. And I'll put a 1 in here. So sensitivity and offset, just assuming a linear calibration. That's already been done, by the way. The good thing about ZP is, and that would therefore predict that that's a 2 millimolar. Now I know it's a little bit less than that. So let me just put in 2 here. I might even put in 4 here. Just bear me with for a second. And then it's going to recalculate at that point. So now it's put it to 0.5 millimolar, and I'll basically leave it at that. But what it means is that what I've shown here is a sort of proof of, demonstration of concept. I would call it less than a proof of concept because I haven't gone through the whole calibration routine properly. But what I'm demonstrating here is that we can take an electrode, or sensor rather, test it with and without the hydroperoxide, clearly see a signal. We can then develop a routine to actually go and analyze that signal automatically and turn that signal into a hydrogen peroxide concentration. As I say, ZP has this platform, so it allows people to go from, oh, you've got this sensor, I'd like to use it in a real world application. Historically, that gap has been quite large, but you can see with this platform, actually, that gap has been significantly shrunk. So that was a demonstration I wanted to do. So in summary, ZP has a very user-friendly platform that allows us to translate sensors that we may already have or assays that we may already have into new world applications. So if you have a new application and let's say our sensor is not already on the SenseItAll platform, and in the case of hydrogen peroxide it's not, then you can engage ZP to do that translation. As I say, hydrogen peroxide is not in this particular case, but we do have, as you see, a very robust technology stack with the ability to make sensors at volume, the ability to have these apps, and the ability the apps on the smartphone, and the ability to have this meter as well. If you have any questions regarding the SenseItAll platform and the translation of sensors into real world applications, don't hesitate to reach out to us. Okay, thanks very much.